Have you ever wondered why a large ship floats but a small pebble sinks? In this video, we'll learn about floating, sinking, pressure, and density. Density is a measure of how heavy something is relative to its size. It can be calculated using this equation. Try calculating the density of a wax candle that has a volume of 2 centimeters cubed and a mass of 1.9 grams. Pause the video to work it out. We can use density to predict whether an object will float or sink when it's placed in a liquid. If the object is more dense than the liquid, it will sink. If the object is less dense than the liquid, it will float. Water has a density of 1 gram per cubic centimeter. Will the wax candle with a density of 0.95 grams per centimeters cube float or sink in water? That's right, the density of the candle is less than the density of water, so it will float. Lead has a density of 11.3 grams per cubic centimeter, and liquid mercury has a density of 13.5 grams per cubic centimeter. What would happen if a block of lead were placed in a beaker of liquid mercury? Pause the video while you think. The lead would float in the liquid mercury. So that's a fairly easy way of explaining why solid blocks float or sink. There is another thing to consider: buoyancy force. All liquids are made up of particles that can slide over each other. When the particles collide, pressure is produced. The pressure in a liquid varies with depth and density and gravitational field strength. In a column of liquid, the water will pour out through the holes in the side of the container. The water that pours out of the hole at the bottom of the container travels further than the water that pours out of the hole at the top. This is because the water at the bottom of the container is under greater pressure than the water at the top. The mass of the particles pushing down on the water at the bottom of the container creates more pressure. The deeper the liquid, the greater the pressure. We can use these facts to derive the formula, where P equals pressure, ρ equals density, H equals depth, and G equals gravitational force. Imagine a cuboid submerged in a tank of liquid. The distance from the surface of the liquid to the bottom of the surface of the box is greater than the distance from the surface of the liquid to the top of the surface of the box, so H2 is bigger than H1. Because P equals ρgh, the pressure on the bottom surface due to the liquid must be greater than the pressure on the top surface. This results in there being more force on the bottom surface of the box than there is on the top surface. The difference between these two forces cause there to be a net force upwards called the buoyancy force or upthrust. If the buoyancy force is greater than the weight of the object will rise up through the liquid. If the buoyancy force is less than the weight of the object will sink. If the buoyancy force is equal to the weight of the object will still float.